In this video, we're going to look at this idea of mutually exclusive events. We'll start by introducing the topic, and then we'll go through some of the key questions that come up in Saxon exams. For those who don't know me, my name is Chris Iannazzoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The whole idea behind mutually exclusive events is that the two events have no overlap. Both cannot be true at the same time. Mathematically speaking, we say that the intersection is equal to 0. That is to say that if you were to plot this on a Venn diagram, the circles would not overlap. A quick example using a deck of cards would be the King of Aces. There is no such card that is both a king and an ace. Those two events, king and ace, are mutually exclusive. If you ever want to prove that two events are mutually exclusive, then all you have to do is show that the intersection between those two events is equal to 0. In this case, we're told that the conditional probability is equal to 0. Well, if we expand that conditional probability out, we can now say that the intersection divided by the conditional is equal to 0. If you then go ahead and multiply both sides of the equation by that conditional, you'll get the result that the intersection must be equal to 0. And as I said earlier, anytime the intersection is equal to 0, the two events must be mutually exclusive. Disproving mutual exclusivity is basically the same thing. We still want to know if the intersection is equal to 0 or not. In this case, we're given the probabilities of two different events, and we're asked to figure out if those events could be mutually exclusive or not. The key to solving this kind of question lies in the union equation. If we plug in our known probabilities into that union equation, we see that they add up to 1.2. From here, we need to ask ourselves, can the intersection be 0? And in this case, it can't. If it was 0, then our union would have a probability that was greater than 1. And that's impossible as far as probability goes. With that in mind, that means that there must be an intersection between those two events. And if that's true, then those events cannot be mutually exclusive. Sometimes the question will tell you if the events are mutually exclusive. All this means for you is that the intersection under these circumstances is going to be 0. That's it. In this example here, we have to find the union between the two events. So step 1 is going to be to expand that out with the union equation. Having done that, we see that there is an intersection term in the union. So all we're going to do is replace that with 0, since we know the events are mutually exclusive. Having done that, we're just going to add up the remaining terms, giving us a final probability of 0.8. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and Sax with detailed solutions. It's pretty cool, you should check it out. I'll see you there.